Okay. Can I move this? Can I stretch this? Oh no. I guess I can't stretch it. I can't like stretch this. I can zoom out, that's true. Should I just do that? Okay, cool. So this is what you guys are going to see on the video. All right, so we're going to continue our notes from yesterday. Yes, recording. Yeah, we talked about the tangent line, and then we talked about the normal line, which is just perpendicular. Was that on your homework, the normal? No? Okay. All right, so example 3 says find the equation for the normal line. Well, in your head, you should think, well, if you're asking for the normal line, that's perpendicular to the tangent line, so I need to find the tangent line first, right? So first, let's find the slope of the tangent. So first, let's find the slope of the tangent. Okay, and if I could just find the slope of the tangent, wait a minute, is this the same problem that we did yesterday? It sure is. So we already know how to find the slope of the tangent, right? The slope of the tangent is -2, okay? All they're asking me to do is to find this guy. That one, right? Right? And so since the slope of the tangent was what? -2, right? What is the slope of the normal going to be? It's going to be the opposite reciprocal, +1/2. Now, if they want an equation, if I want to find an equation of a line, what two things do I need? Huh? A point and slope. We have the slope, right? We have the slope. We just need line equation. Yeah, it's the same point because we want it to be the normal. I mean, there's normals everywhere, but what normal do we want? We want the normal at x equals 1, the problem said. So this normal, right? So we have to use the same point. We have to use this point, right? So the point is going to still be 1, -3. Where did I get that -1 from? The 1 is from here. Where did I get the 3 from? -3 from? Well, from plugging in 1 here, right? 1 squared minus 4, that gives you -3. So that's where that -3 came from. So if I have a point and a slope, that's easy. All I'm going to do is y minus -3 equals 1/2 times x minus 1. And that's my equation. But a lot of times, I just like to, that's a +3. I'm going to just move that to the other side. So y equals 1/2 x minus 1 minus 3. And I could leave it like that, and that's fine. Okay, you could put it in slope-intercept form, y equals mx plus b form if you like, but you don't have to. Oh, here we go. It asked me to graph it, so that's easy. I'm just gonna do a sketch, quick sketch here. We kind of did it yesterday. Oh my goodness. At least on Docere I could undo that. Oops. So there's my graph. And my tangent line was, okay, so this is 2, so this is 1. At 1, our tangent line was going to be something like this. And our normal line was going to be something like this. Right? And this actually has applications in physics. Believe it or not. Yeah, definitely. Okay? All right. Can you guys do number 2? Example 4. Can you try that with your partner? It says find the slope of the curve at x equals a.
So when it talks about the slope of the curve, it has to be.
Yeah, so the slope of the curve, how do I know the slope of a curve? That really is the slope of the The tangent line, good. At x equals a. Now a represents a constant. So it could have been 2, it could have been 1, it could have been -3, but we're just talking about any old constant. So the way you're going to find that slope is you're going to do the limit as h goes to 0 of f of what?
2 over 8.
Well, okay, let's just f of a plus h, because it's x plus h, but our x is a, right? Minus f of a over h, and then I want you to take it from here. Okay, so I'm going to pause this video, and you guys work on it. You might need some space, so you might have to write this all over.
We did find that.
Bach minus Bach over. No, we found the average rate of change. That was
Okay, that's not any of this.
homework wasn't asking for it.
Just to find the slope.
So, homework wasn't asking for it.
Plug it in and ask to find the
No,
slope.
you have to
Plug it anyway. Oh.
Okay, you plugged it.
It should really give you more space for this question. No, that's the function. So the function, yes.
Yeah,
Wait, what?
plugged it. Oh, wait.
So f of 2 is going to be f of 2 over 8 plus h minus f of 2 over x. F of 2 over why did you get f over 8?
Oh, wait. Where did you get A? So this is H.
Yeah, f of a is plug in a.
Am I right?
I think so. Yeah, this is.
You just plugged this. Okay, what did you do? Yeah, you did.
F of 2, okay. Yep. And it's variable.
We should have this for the next step, right?
Yeah.
Okay. And then show me your wonderful algebra skills. Until you actually substitute.
Do we both? We gotta get a common denominator. No, we can't.
Mm-hmm.
Oh, yes, we do.
Just to make this clear, I'm sorry I'm like repeating, but
Okay.
like, this is the same thing as an equal rate of change, right? What do you?
This is the average rate of change.
You know, you have to get the common denominator at the bottom.
The limit of the average rate of change.
When you add an H, like, how do you add it?
Yep. Exactly. Good. No, this is important that you're making these connections. It makes sense that you're struggling with it.
Wait, you can make it 2 over a plus h over h, and then minus 2 over a over h. That's what I did. But then won't the h's cancel out? No. Wait. Yeah. You separated? Yeah.
They will.
So then you can just cross them out right now then. Can't you? Yeah. This one?
Yeah.
Can't you just cross out the h's right now?
No. These?
Yeah.
No.
No?
That's horrendous. No. If you had 2 over 3 plus 4 first of all, this is addition. This happens first. When you have a denominator like this, it's like, this is not a 4, it's a 7. You have to imagine that there's a parentheses there. So you can't just go in and take that 4. If you had a multiple of 4 here and a multiple of 4 there, then you can do that.
But isn't it different with variables because you can't add variables?
No, it's not different.
So
you can add
that can equal a.
Yeah.
No. You need a common denominator. You need to multiply this by a and this by a plus h. Oh, but you need a parentheses here, otherwise it's wrong. Well, you guys should be getting negative 2 over something. Good. Not all over. Oh, yes. Keep going. You have 2 more steps. Should we do it together now?
Yes. No, give me like 2 more minutes.
2? 1.
Minute and a half.
1 more minute.
Are we supposed to plug in 0?
Yes. Because we're finding the limit.
That's what I got.
No.
So we have negative 2 over a squared plus a over h. Don't you multiply by what is this right now? Don't you multiply by 1 over h? Yeah, that's what I did. Right? That's what I got. Get h out of the box.
Then you have to.
That's what I got right here.
Okay, let's go over it together. Alright, so,
Yeah. That's right.
alright. Ooh la la. Okay, so what I'm gonna do, I really don't like to do math sideways. I like to go long, but since this is really squish, I'm doing it sideways, okay? This since there's like already denominators up here, this whole denominator, it bothers me. I'm just gonna get it out of the way temporarily by just bringing it out. I can do that, right? That's allowed. Okay? All I did was, this is 1 over h essentially, so I pulled it out. But I want a common denominator, so I'm gonna go ahead and multiply this by a over a, and I'm going to multiply this by a plus h over a plus h. Okay? Is that okay? Let's move this over here. Okay. Now, so then I have the limit as h goes to 0 of 1 over h times 2a minus 2a plus h over a times a plus h. Yeah? which equals the limit as h goes to 0 of 1 over h times 2a minus 2a minus 2h over a squared plus ah. Okay? Which is the limit as h goes to 0 of 1 over h times, well, 2a minus 2a cancels, right? So that's going to be negative 2, but, okay, fine. Negative 2h over a squared plus ah. Do you see it now? What can I do? Cancel what? This h and that h. Because that h bothered me a lot because that would make the whole thing go to have 0 in the denominator, right? That changes everything. Because now, can I actually substitute h into this 0 into this remaining h? Yes, this whole thing will go to 0. But that's okay because that's not the only thing in my denominator. So now I don't have to write the limit anymore. It's going to be negative 2 over a squared. Okay? The goal is to get it so that you can substitute h equals 0 without making your denominator go to 0.
Does the answer negative 2?
Yep. Negative 2 over a squared.
If we had wrote, even if we had wrote it all that.
Had written it?
Yeah, where did the plus h go?
Plus ah?
Yeah.
Because I substituted, how do you find a limit? Your first step is to substitute h equals 0 into this. So a times 0 is 0. What other way?
But didn't you cancel out the h's?
I canceled out this h
Oh,
with this
okay.
h. This, because this is a multiple. Here I can do that because this is 1 times negative 2h over h over this. So I can't just cancel these guys or these guys. No, because this is a binomial. But these guys are separate multiples, so I can cancel those. Does that make sense? No? So if I had 2 over 3 times 3 over 5 plus 3, okay? I cannot cancel this 3 and this 3. No, because this is not 3. This is 5 plus 3. I can't do that. But I sure can do that. Right? This I can do. This I cannot do.
The bottom technically saying 8 times h. So isn't it like 5 times 3?
No. This 5 is talking about this number right here.
Oh.
Okay? Do you guys see how I did that? Now let's think about what that actually means. If I have a graph of 2 over x, any point that I pick for my x value, any a value, no matter what's the slope of the curve going to be? Negative 2 over a squared. So what kind of number, think about whatever, doesn't matter what you put into a, what happens to this negative 2 over a squared? What happens to that? It's always going to be negative. So that suggests that my graph, the slope of that graph is always going to be negative. And if you think about it, do you guys know how to graph 2 over x? The parent graph is y equals 1 over x, right? Which is a hyperbola, right? And if you think about it, that tangent is always going to have a negative slope. Do you see? Do you see what I'm saying? It's always has a negative slope, the tangents. There's no tangent lines that go this way. The tangent lines always go this way. Okay? But the question asks, okay, so at least let's record that. The slope of the tangent of y equals 2 over x is always negative. Negatory. Negative. But what happens as x changes? Oh, as a changes. A can be any constant for the x value. So let's think about what happens as I'm gonna just draw this. Oh, so you still writing this? Tangent, slope of the tangent is always that. Okay, so let's think about. Think about when x is very. Oh, sorry. Okay. So messy. I hate that. I hate being messy. Okay, so let's say a is very negative. Okay, like a negative 1,000. Okay, what happens here? This is gonna be positive 100,000 or something like that, some big number. It's gonna be a very, very big, very, very small negative number. So that means the graph, what the tangent, the slope of the curve is gonna be very what? It's negative, but the slope is gonna be, is it gonna be really steep? No, it's gonna be almost flat, right? And then what happens as our a moves closer? So let's say a equaled that, but let's say a is like negative 0.001, really close to 0. What happens to this? This number's gonna be really big, right? It's still negative though, but it's gonna be really big, meaning the slope is very steep, right? What about here? When the a is a really, really small decimal, but it's positive. It's gonna be a really big number, right? Again, in fact, is this number and this number going to give you different outputs? No. It's going to give you the same slope, huh? Because when you square it, this slope and this slope should be the same, so it should be symmetrical, yeah? And then if we have a really big number like 1,000, 1,000 squared is 100,000, and then negative 2 divided by 100,000 is going to be a very small number, but it's still going to be negative, so it's going to be very flat, but still negative. Almost flat. You see what I'm saying? Yeah? I feel like I have a tendency to look over here because my seat is like this. Yeah? Okay? Alright, so how can we say this? The slope is always negative. I mean, we can say it in different ways. How about we say this? The tangents are very steep and negative near x equals 0 and nearly horizontal, yet still negative, okay, as x moves away from the origin. It's not the best, but that's the description. Ah, look at the time. Sorry for my sloppy writing. All right. Hold on. Next page. Did you write it? Hurry up. Okay, so the slope, we've already talked about this. The slope of the tangent line always gives us the instantaneous rate of change at any time t, or we could call that the instantaneous, if we're talking about movement, velocity. Okay? Instantaneous velocity. What's the difference between velocity and speed? Velocity has direction. Very good. Okay? So lastly, we might have to go a minute over, but let's just talk about this last example. The equation for free fall. This is a real example. The equation for free fall at the surface of Jupiter is S. S stands for position. Position is 11.44 t squared meters. With t in seconds. So depending on how many seconds you've been falling, your position's gonna change. It really should be, yeah. Anyway, yeah, it should be negative. Anyway, assume maybe things fall up in Jupiter. Assume a rock is dropped from a 500-foot cliff. Okay, on Jupiter, and find the speed of the rock at t equals 2. If I want to know the speed, okay, first of all, this is not giving you the speed. This equation is giving you the what? The S stands for the position, okay? With respect to time, as a function of time, okay? If I give you the position, but I want to know what is the rate of change of position? That's velocity, right? How fast is position changing with respect to time? That's velocity. How fast is velocity changing with respect to time? That's called acceleration. Okay, so if I want to find the speed of the rock, because you know the speed changes, right? You don't, when you drop something, it doesn't fall at a constant rate the whole time. It's like, actually, does it?
In a
No.
vacuum it does.
Gravity operates on it, so it starts falling faster and faster, right? Right?
Meters.
So, because gravity, the effects of gravity. Okay, so find the speed. How do you find that speed? By finding the rate of change of the s. So you're finding the tangent or the slope of the s. So what do you have to do? You have to do the limit of this function. So I'm going to just put it right here. You guys could go ahead and take a picture of it if you like, because it's lunchtime. But that would be how you do the problem. Okay? Or I'm going to post this video online so you could also look at it that way. Okay? So your homework is to do the next section, 2-4B. Sorry. 2-4B. Yeah, I'm gonna post this online.
Brittany, oh my.
Yes, I will post the second part of yesterday's video.
Are you done?
2-4B is for problems, okay, on rates of change.
Wait, what?
Okay?
Oh, sorry.